Hello, this is Clayton Balmas, and I'm your teacher here today in our audio classroom with SynMax University here at synmaxperformancelubricants.com. Today, we're going to be talking about the simple engine coolant system performance measurements in our presentation. Now, the purpose of this presentation is to provide real-time, on-track, simple and basic points of engine and coolant system measurement. We need this to verify the true performance of the overall coolant system, because it might be running hot and you don't know why. So let's find out where it's happening. You see, this information is needed in order to determine coolant system performance, radiator performance, and engine coolant system performance. Now, I want to dedicate this to a friend of mine, which passed away here in 2011. His name was Mike Evans. He was the lead thermal systems engineer at Roush Powertrain Engineering in Detroit. And he taught me these things, and now I'm able to share this information with you. And he taught me a lot of the things in the coolant system. So you're able to get the teaching of some of the most advanced engineers in the world. So let's go on. Not me, of course. Anyway, on the points of coolant system measurement, we have to take the measurement, and it's very simple and easy. You can just use a laser heat gun and point it directly at the point of measurement. You see, if we were at like Roush Powertrain Engineering or wherever, and we were doing an OEM system, right, test, we'd use a controlled atmospheric chamber costing about $2,000 an hour with a multiple repeatability test, all right? But this simple method will cost you about $50 for a heat gun and your time, and it's a little less precise, but pretty close to the same accuracy to get you pretty solid direction in how all is working. Now, you have to first have a baseline or know your car. We need to have a repeatability test of at least 3 times minimum, and try to create the same setting as the outside temperature of when you're doing it for repeatability. And the best temperature for nucleic boil and system boil and everything to be right on is about 85 degrees Fahrenheit. Now, what I need you to do is when you're coming off the track or driving off the road, now I want you to know that this is more than racing. This can apply to your truck, it can apply to your car, it can apply to any coolant system. All right, it's not just limited to racing. So let's say you're in a racing situation. You got your late model or your sports car there, or whatever. But when coming off the track hot, when you stop into the pits, perform this quickly before the heat soak comes in. All right, and the test needs to be repeatable. Now, if you don't have a fan system, try to have a fan blowing some air for the moment while you're taking these temperature measurements. Take the data information and create your own average and final determination. You see, one thing that Mike told me was this: in God we trust, everybody else bring data. Okay? So this one here is some data that we've got to try to get. Now, for the thermostat, if you want an exact position, if you're using a thermostat, try to make sure that it's not moving and the thermostat is pinned open, because the slightest variable in movement, even an eighth of an inch, under certain conditions could affect the performance about 10 or 20 degrees Fahrenheit. So we got to watch out for that. Now in the measurement point areas, we're going to have the thermostat, in the front of the engine, wherever it's at. The cylinder head, usually this is where your temperature gauge is at. And you're going to find out that the cylinder head is going to be running probably about 20 degrees hotter than the actual thermostat. Something to look for there. The inlet on the water in the upper radiator, the outlet of the water where it's going to be cool. Maybe now try to get it right on the connection end or the core, okay, right before the hose if you can. And if you have an oil cooler inside of the radiator or outside, you can take those temperatures as well. Remember, the temperature measurement is more than just a single gauge probe coming off the head of the block. All right, that's just one temperature. You're going to find out that you're going to encounter, as I said, about 4 different temperatures for you to make a determination of what's going on. Again, here's the coolant system measurement points. Here's the upper radiator, lower radiator, thermostat, cylinder head. If you have an oil cooler, the inlet and the outlet on the oil cooler. Now, for the radiator performance measurement, the key is to discover if the radiator and coolant chemistry is working at premium efficiency. Okay? Which is the difference between the inlet and the outlet of the radiator. See, because the water is cooled as it passes over the cooling tubes. The temperature difference between the inlet and the outlet, or the cold, is an engineering term called a delta T. Okay? Now, the inlet water, hot, which will be probably the upper radiator connection, or the cooler, which is the lower radiator connection. All right? What we're trying to determine is what's called a delta T difference. Okay? Now, for the premium chemistry optimum, whatever you're using, if you're averaging about between 37 to 40 degrees temperature difference from the inlet to the outlet, you're doing a good job. I mean, it's hard to get better than that. All right? If it's not doing that, and all of a sudden it says 30 degrees or 25 degrees or 15 degrees, one out of two things are happening. Either the radiator is plugged or the chemistry isn't working. Okay? Now, again, here is the radiator performance measurement. All right? To determine the delta T, you got the hot coming in and the cold going out. And the difference between the two is your delta T measurement. Now, we have to remember that the cooling tubes on the inside have to be clean of insulation or dirt, and that the hot fluid is going to move through to touch the metal surface for the heat transfer, and we have to have the maximum allowable of airflow for the heat transfer to work. All right. Now, also, an advanced water chemistry will provide a surface coating and cleansing for the chemistry to work 100%. So that's what we're trying to determine. Now again, the reason for the delta T difference is to ensure is the radiator working at its 100% efficiency. Now this same theory can work on your intercooler for your supercharger, your oil cooler, or whatever coolers that you're working with, or heat exchangers. Is the water chemistry and the heat transfer performing at its full efficiency? And the reason for the engine measurement is to assure, is the thermostat really open all the time? Okay? We want to ensure that the water chemistry is protecting and pulling heat from the hotspot components and under the extreme, and here's why. Under extreme and long endurance conditions, advanced water chemistry will maintain your thermal performance repeatability. So as Mike Evans told me, in God we trust, and everybody bring data. All right? So there we go. So one of the resolutions for this is we've got our SynMax water cooler system treatment. This here is the concentrate, and inside you'll be able to have all the chemistries that you need. You need to mix this with purified water, or if you've got a 50-50 glycol in your antifreeze, that's great. Or if in your racing system, you got the good 7.0 water, you can mix it right straight in, and you'll have all the advanced scientific formulation additives that you need. Here we have the water cooler premix. It's a 1-gallon jug. It has the exact chemistry mixture with 7.0 purified water. Now the applications on this are very simple. You can use it 100% direct in your racing system. You also can use it for all weather. You can mix it a 1-to-1 ratio, 1 gallon of premix to 1 gallon of glycol for your all weather antifreeze needs. Use it in gasoline, diesel, or flex fuel. And furthermore, you can use it in your intercooler for your turbocharger or supercharger. So this is the end of our presentation for the coolant system performance measurements. And so this is Clayton Balmas here at SynMax University at synmaxperformancelubricants.com. I also encourage you to please look at the remainder of our presentations. I think you'll find them very encouraging on our coolant system performance and how to protect things, whether it's racing or industrial. So we'll see you at our next session, and I hope you enjoyed listening to this as I enjoyed sharing it with you. So bye now. See you at our next time. For technical, test, and brochure information on how the Aerospace Advantage for Motorsports can work with your race team or other commercial requirements, please visit us at synmaxperformancelubricants.com.